Another pitfall is to design things like workstation with fixed structures. When you go into lean culture, it means that things will change constantly. People will challenge the way that you are doing things. So you need to have flexible structures.
So good morning, David. I'm glad you're with us this morning to talk about a subject that you hear a lot in the different companies that I do visit, implementing the one-piece flow.
Thank you, Mathieu. My name is David Nobert. I'm an industrial engineer. I've been working for the last 15 years in companies implementing lean principles, continuous flow as one. And now for the last 6 years, I've been working at Createch. Createch is a company that aims at improving significantly the efficiency of its customers while doing two types of intervention. First, we implement world-class ERP softwares such as SAP, Microsoft. And we also work very hard, and this is the team that I'm working in it. It's we are looking at the processes. It's either shop floor processes or business process itself. So we are working. So my team, we are working at on the shop floor and in the processes in the businesses. And always keeping in mind the lean principles, which aims at reducing waste.
To begin with the continuous flow, which waste and in what context you need to implement the one-piece flow?
The one-piece flow is very, very useful in order to reduce the shop floor space required to produce the products because it reduces significantly the inventory on the shop floor itself. So if you recall the 8 wastes, which are the transport, inventory, motion, waiting, overprocessing, overproducing, and defect, plus unused skills of employees. Out of those 8 wastes, the one-piece flow will reduce the inventory, some motion, some transport, some waiting also. So it helps a lot implementing lean culture.
So you decided you eliminated waste. Now where you start? I'm pretty sure you don't start with all the products you have in house and say, okay, now we're one-piece flow with everything. Where to begin? First,
we have to decide which product we want to produce in the cell. Usually we're gonna have to start with not too complex products to maximize our chances to have success at first. But also we have to weigh in the fact that we want to also have an impact on the business on the business. So we want to select products that are significant for the business. We also want to select products that are at a certain level of maturity. We don't want to put in cells or in continuous flow products that are going to fail 1 out of 2. And also, it's very important to have pretty solid forecasts in terms of sales for those products for the future.
Why do you mean the forecast is important on the mature products?
When we design a cell, we have to take into account the takt time, the takt time for those products that we want to produce in those cells. The takt time is not defined by the company itself. Of course, it's defined by the customer. The takt time is the rhythm at which the customer will want those products. For instance,
that's what they mean, the pull. So the customer pull on the products. So the cell needs to be delivering a takt time from this demand.
The pull is not necessarily the takt time is one thing, and you may want to put in place a pull system down the road, but the takt time is simply the rhythm at which the customer will ask for.
Okay, ask it. It's different. Yeah.
So and when it's only when we have that type of velocity required that we can design our cell down the road. So our continuous flow. So that's the two very important things. So which product we want to produce in that cell, and what is the velocity of that product.
The next factor is work elements. So can you help us to know what are the work elements that need to be put in place to make it a success?
The work elements are the element of work required to transform the product. Let's say it can be either to screw some screws on the casing, to weld some parts. So those elements need to be analyzed or at least documented at first in order to assess how much work need to be done on that product. So after that, we will have to determine how much time is required for each of those elements. So once we have those two informations, then we can relate that to the takt time and say, well, if I need to produce a product every minute, and I have, let's say, 2 minutes worth of work to do on those products. So it means that we will have to maybe split the work content in two. So we will have two employees working together in order to assess and to produce a part every minute.
Okay.
So that's the key point.
What happens when you have 16 different the work elements to go through 12 employees? How do you manage to put all this together, and where do you aim?
While we do the documentation of all those steps, we will also challenge those steps. We will make sure that what we document is the best way of doing that activity. So what we do, we do paper Kaizen when we do that type of activity with the employees. Okay. So for each step, we ask the employee, okay, is it the best way to achieve that task? What prevents you to be more efficient for that task? Is there any automation that we can put in place in order to help you out? So in the context of employee shortage, it's a very, very important step. Okay. It's also a very important step because this is where we will decide when we will where we will break the work between 2, 3, 4 employees. So by making those employees participate to that activity, the change management will be a lot easier.
So you sit with your employees and they tell you, okay, good, this is the best way to do it. And now on the paper Kaizen, you know the employee said is the best way, and it's 2 minutes. So you start from there. So this is the data that you're gonna put into this big formula for you to decide on whether or not you need to do sub-assembly, whether or not you need to add capacity or add employees. Can you let us know how you define all that?
Yeah, of course, sub-assemblies are very, very useful when we have complex assemblies to do, complex products to assemble. First, because when we make sub-assemblies, it means that we will have maybe 1 or 2 employees working at the same time on the same product. So the lead time is reduced for the customer. Also, we can specialize some workstations to do some kind of task. For instance, if it involves some epoxy, if it involves some special tooling, so we can design the workstation very specifically for that kind of activity and be more efficient and also save some space. Our compass while designing a cell is always and will always be the takt time. We have to make sure that every workstation that we design is able to produce at the takt time. So let's say that we have a takt time of 2 minutes. So all the steps done on a specific workstation cannot altogether sum more than 2 minutes. Even more, if we want to be more specific, it would be 80% of those 2 minutes to make sure that that workstation will be able to produce to the takt time. So we will separate. We will separate the work element in order to be able to match that takt time. So let's say that we have 16 minutes and 2 minutes of takt time. So we will need around 8 workstations.
Okay, 8 workstations doing that and pushing to the next one, the next operator or work element.
That's it.
You obviously do all the financial work on the automation, but sometimes when you say 16, adding 8 people, it's not doable. So this is where you're gonna try to automation the operation so it can go faster.
But the automation is useful usually when we want to save employee time and make some very simple tasks that are repetitive and put employees at risk for some injuries, for instance. Also, in the context again of employee shortage, it may be a good idea to automate some very easy tasks that doesn't require human intervention.
So once we look at all the equipment, all the people we need, all the tooling we need, we did the footprint of the area that is for these products. What are the next steps?
The next step is simply to make things happen.
Happen.
Physically.
Go to action.
Physically. So what we do then is simply to draw a line of all the equipment that we need, linear, not trying to make it a U, L shape, E shape, whatever shape. We want to just see how it looks like in a linear way. Once we have a good idea of how the part will be transferred from one workstation to the other, then we can start making it the right shape. But we always have to take into account or keep in mind that we will have to manage 3 kinds of flow. First, the material flow, the one that we are talking about since the beginning of this interview, the thing, the product.
Yeah,
so
the
how is
coffee maker, the toaster, the thing, like what you decided to produce.
So this you also want to draw that on your layout to understand where the things will flow. The second flow that you need to take into account is the human flow. If your human will have to your employee will have to go from one place to the other, how is it going to happen? Is it going to be safe? Is it going to be efficient? Is it going to be easy? So this has to be taken into account too. And the last one is the information. how is the information will be transferred from one workstation to the other. For instance, when you draw that type of layout, you want to also define how is your workstation going to be replenished for screws, for the parts. For instance, you will, in most cases, you want to have a replenishment by the back of the workstation. Why? It's because you don't want the employee flow and the material flow to interfere together.
Yeah, that makes sense. Yeah. So this is where you're gonna put all the tools and the pieces. Very like it's not placed that way. It's placed that way for a reason. So you can reach with your hand like that, because the other part is upside down. So you're gonna go and take a look at all this for the replenishment of different element of work.
Yes. When you go into detailed design of each of those stations, you want to go into that type of detail. How are you going to present? How are you going to give the part to the employee? So it's going to be easy for him to assemble it. It's going to be hard for him to make mistakes. If you give the employee the part in one way, but the employee has to flip it to assemble it the other way, there's some chances that mistakes will happen, or even
confusion. Yeah.
Confusion. So you want to make it as easy as possible for the employee while they assemble on the line.
So we put all the flue, the three different flue, the human, the material, and the information, did all that, and now we're ready to action. We need to accumulate data. There's a lot of things needs to be done so we can get it more efficient, get our people involved. Can you tell us let's say the biggest requirement to go on with the one piece flow, and also the pitfalls that needs to be considered before going forward?
The first, I would say, there's quite a few
important
things to take into account for sure. But one very important is the employee agility or polyvalence. As I mentioned earlier, it's going to be fairly hard to balance the work between employees. So what will happen is, in some cases, you may have 5 workstations with 4 employees. So you're going to have employees that are working on different workstations. It means that employees need to have a larger spectrum of skills in order to achieve the work that they are supposed to do. That may be difficult in some cases. So you have to be aware of that. Another pitfall is to design things like workstation with fixed structures. One thing is sure: when you do when you go into lean culture, it means that things will change constantly. People will challenge the way that you are doing things. So you need to have flexible structures. All kind of, the different type of activities requires different type of workstations, of course. And if you need, let's say, 16 inches by 16 inches to do your work, but you have 5 feet by 3 feet, one thing is sure: the excess amount of space will be filled with different kind of stuff that is useless for the employees, that will create confusion, and that will require some more space on the shop floor, which we don't want. We want to add value on the shop floor. We don't want to stock useless matter.
when we went to school, we get an A, a B, or a C. Like you know where you need to put your focus. So KPI on a shop floor is very important. How do you manage the employee to get involved with the KPI and understanding the
KPIs? The biggest change in a cell compared to a department is the employee will have to work together. There's no need to measure individuals in a cell.
Okay.
What you want to measure is the output of the team, is the cell itself, because people will move within the cell in most cases. So it's irrelevant to measure employee by employee. It means that you need some kind of leadership in your cell. And usually it's either a team lead that we want to put in place in the cell, a team lead that will, in some cases, replace when people are sick or go to the bathroom, or if there's any issues, they will work. But most of their time, they will make sure that the cell is working properly. So you need that type of leadership that will also be accountable in some way of the result of the cell. So the last thing that you want to do is to put in place cells without measuring the output.
Yeah, what doesn't get measured doesn't get done first, and now you need to aim at where you want to get better.
Exactly, and things need to make sense for the employee. So if an employee just go in a cell and is asked to do some type of work to change from one workstation to the other, but doesn't know, was it a good day? Was it a bad day? It doesn't make sense for him or for her. So you need to put in place KPIs, not to control people. It's simply to mobilize them, to show them the objective, and to compare where they are according to that objective. And then if they struggle to achieve that objective, to offer them their support to improve the workstation, to improve the methods in order to match that objective.
Okay, so if I understand it well, you need someone with good leadership, being able to mobilize everyone to create a continuous flow and making sure that everything drips out well all the way to the customer. We didn't talk about quality. Can you let us at the end on the note where how does it improve quality?
The first factor that will impact quality when we implement cells is purely mathematics. If let's say that you have first 3 steps to do when you do your part, your thing. And in the past, you were in departments, so people were making batches of parts for step 1, 2, and 3. Let's say that the batches were 50 parts, let's say, and the step 1 did a mistake on the setup, and the parts are not as they were supposed to be. So it may require, let's say, to the step 3 to notice that there's a mistake there. So when they will find out that there's an issue with the part, it may be too late, and the old batch may be processed. So it means that you may have hundreds of parts that are not according to the specifications before you even know that. On the other side, if you are in a cell and then your step 1 is 2 steps from the step 3, and you process at the step 1, and then you pass to the step 2 and to the step 3, with no inventory between them, you will find out pretty fast that there's an issue with the part.
Okay.
So simply with that type of situation, you can imagine, you can see that the quality will be greatly improved.
Yeah.
This is only
no inventory and no inventory, no defects. It brings us to the principle of lean, of elimination of the waste, and those are other good things to put in place at one piece flow.
Of course, and also simply by stacking parts on a cart and transporting that cart in the shop, you may break some parts. You may make some defects. So the one-piece flow is really a good, I would say, a good way to reduce the defects.
Because at the end of the interview, the product goes from raw material to finished goods and packaging at the same time. 2 minutes in, 2 minutes out. Put that on the skid, and now transportation is right to the customer, not into inventory, or if it could happen, but most of the time is just in time to our customer. As we said, the takt time is decided by the customer needs.
That's it.
Do you agree? Do you agree on that? I haven't been a good student of the one-piece flow here today.
Yes, of course.
So you did a great job. Thanks a lot for getting with us at Flexpipe Lean Makers.